let's continue with today's lesson, strength transformation. You may wonder why we need to learn both stress transformation and strength transformation. It basically, in the real world, it's difficult to measure stress on the member. So normally we do indirectly. We measure strain and then convert to stress. And that is what we do for the remaining of today's class. Before that, I just want to, this video, we want to show how to set up and to solve for the strains. So let's say solving for strain. And always start with a few notes. And I just mentioned often easier to measure strain than stress. And field measurement is possible. Field measurement possible for strength. How? Basically, we install strain gauge to measure strain. So it will strain gauge, and that also the purpose for lab number 3 that we have it today, bending lab. Strain gauge, and also you see how to apply the strain gauge on the member with the previous lesson we're talking about. So strain gauge measure epsilon x apostrophe directly. And for that, you may wonder what is strain gauge. So basically, this is a strain gauge and applied to a member. So very small, and they come with many times applied to the member. So what the member have a load, then the load create the stress, and then it create the deformation on the member, and that deformation will the strain gauge read the strain, and that strain later on we convert to the stress. So let's show you a short video of what is strain gauge, and then we go back to apply with the equation. What is a strain gauge? About what consists of strain gauge. And they can attach bonded to a member, structural member. And with the ohm meter to measure the strain, normal strain. They come with many different configurations, different types, as you can see here. So with that, go back to the lesson. So you already know what is strain and how they install in the structural member. So with that, let's put a general application of a strain in a member. So let's put it XY, and in any axis, for example, X apostrophe, we put a strain gauge along that axis that you show there. Then form an angle theta from the original axis X. Then we have equation, and as you can see, if you put the strain gauge in the X apostrophe, what the reading in there, it will be Fx apostrophe, not Fx, not epsilon X, not epsilon Y, epsilon X apostrophe. But we interest in determine epsilon X, epsilon Y, and gamma X and Y, gamma XY. So how can you do that? And if you recall the equation that we learned in the stress transformation here, the previous lesson, after we draw this and we do with the sum of all the forces and divide by dA, we have this equation. Everyone see that, right? Go back to the previous lesson, stress transformation. And that with the trigonometric substitution, we have sigma X apostrophe equal to that. So basically the original equation is here. Epsilon X X apostrophe, sigma X cosine square theta, sigma Y sine square theta, 2 tau XY sine theta cosine theta. So with that, we can write, instead of write that equation after substitution, we can use this equation directly, and that's what I'm going to write here, as you can see. So you have that is epsilon X apostrophe equal to epsilon X cosine square theta, and then we have epsilon Y sine square theta, and we also have over there it have 2 tau xy sine theta cosine theta, but 2 tau it become gamma because tau is gamma x over 2 for analogous, if you remember. So it will be gamma xy cosine theta sine theta. And with that, as you can see, with the one strain gauge, it only have one reading, epsilon X apostrophe. But in this equation, we have three unknowns, epsilon X, epsilon Y, and gamma XY. So basically, we have one equation and three unknowns, which is, I just mentioned, epsilon X, epsilon Y, and gamma XY, when we only measure epsilon X apostrophe. So how can we do with that? Just keep in mind, we have one equation. If we apply, if we instead of install only one strain gauge, we can install three of them. Then we have three equations. And then with that three unknowns, we can be able to solve. So as you can see, and that come up to the next topic is the strain gauge Rossette, right? So strain gauge Rossette. So where we can install three strain gauge like a Rossette setting. So strain Rossette. So like a Rossette, so it's here we have still have X and Y, that either axis or plane that we interest, and we applied three different strain gauge at three different direction. So three different direction there. So we put three strain gauge. And that let's call that is the reading. Corresponding reading for that is epsilon A. The reading from the next strain gauge epsilon B, and the next reading is epsilon C. Epsilon C, three readings. And of course, if we apply that, we can be able to measure the angle from the x-axis for this strain gauge, so that we got theta A, and of course that angle we can theta B, and the next angle is onward from the x, as you can see there, theta C. Then use the same equation that we have it here, we can have three equations. So let's rewrite that three equation, and we can go ahead to use worksheet 13A to solve the problem in here. So that here, epsilon A, we can rewrite with that equation, as you can see there, epsilon x cosine theta A can be measured, epsilon A can be measured, plus epsilon y sine square theta A. So since I call that A capital, then let's put that here capital. So theta A, theta B, theta C, and then we have plus gamma xy cosine theta A cosine sine theta A. And then we have epsilon B equal to epsilon x cosine theta B square, epsilon sine square theta B, epsilon xy cosine theta B sine theta B, and epsilon C, which we can measure from strain gauge, and we have epsilon x cosine square theta C plus epsilon y sine square theta C plus gamma xy cosine theta C sine theta C. With that, as you can see, we have three equations and three unknowns. Still three unknowns there, which is again epsilon x, epsilon y, and gamma xy, and that it will be the happy phase in here, compared to this one is unhappy phase, and you want to see that. So as you can see in the real life application, we just apply the three strain in the Rossette setting, and then we have three equations to solve. So let's apply to the worksheet 13A, and then we move on to and 13B, and then we move on to the generalized Hooke laws later on, and then we move on to the worksheet 13C.